Hello and welcome. Today we are talking about unlocking the potential, 5 essential questions to ask about CAD and CAM software for additive manufacturing. Joining us today, we have Jose Coronado, the CAD Product Management Director at PTC. Thank you for joining us today.
Thank you for having me.
So before I start with my questions, Jose, why don't you tell me a little bit about your role at PTC?
Yes, I'm product manager. Basically, I'm responsible for the manufacturing extensions of Creo, being this machining type of software, inspection, mold design, and specifically additive manufacturing.
Great. Well, thank you very much again for being here. So what specific tools or modules does your CAD CAM software, Creo, offer to support generative design for additive manufacturing processes?
Good question. Okay, yes, we have been working on additive manufacturing space. So obviously, Creo as a CAD system have been in the market for many, many years. Specifically, I got the assignment to work on the additive manufacturing space since our Creo 4 M40 development cycle. So basically 8 years ago. So we started supporting initially direct connections with printer manufacturers. Then we added lattice modeling. And after an acquisition, PTC acquired a company, we started supporting generative design. So all these different components that play very well together in relation to additive manufacturing work completely seamlessly integrated inside Creo as a CAD system.
Okay, terrific. So question number 2. How does Creo integrate with simulation and analysis tools to optimize designs for additive manufacturing?
So Creo, as a CAD system, can provide to the users different finite element analysis simulation tools. Maybe I will elaborate on one in specific, which is real-time simulation. So we have Creo functionality for real-time simulation, and these models that we are preparing for 3D printing, it can be generative design or could be lattices, very complex lattices with thousands of beams, for instance, can very well be simulated in real time with Creo simulation capabilities. There are more tools. There are more tools to simulate a structural model, thermal, fluids, etc. The real-time simulation capabilities is one. We have Creo Simulate, which is another one. We have full simulation capabilities based on ANSYS solvers. So, and if in the case that the users require for some reason an external finite element analysis simulator, yes, we can also support send the complete 3D model to those solvers and then get the simulation back. And even get that simulation that was optimized using an external software can be even used to, for instance, to do an optimization of our own lattice modeling, which is part of the additive manufacturing capabilities.
Okay. All right. Now, the third question I have is, can your software facilitate the seamless transition from that CAD modeling to a CAM tool path generation for additive manufacturing equipment? And if it can you please explain that?
Yeah. Oh, 100%. Creo, since the beginning, all the components that we integrated inside Creo work seamlessly. So the user can create a 3D model. This 3D model is, let's say, full boundary representation, full BREP model. Then you can create some generative design model of lattices, etc., and then simulate everything. And when you are ready, you say, okay, this is the component, the part that I'm producing, and it's performing as expected. We have tools in Creo to prepare for 3D printing. So it's, in our case, we call it a tray assembly. That is a special type of an assembly to prepare the job for printing. So in the tray assembly, in this environment, is a job preparation environment. You using the 3D model that you just defined and optimized using simulation, you can add the support structures needed. You can do the slices needed as a preparation for sending the files to the printers. And depending on the printer manufacturer, because printer manufacturers can require CLI files, for instance. Okay, we can create CLI files. Some others, from polymer printers, etc., they prefer to use 3MF because it's more efficient. Okay, we can create 3MF files. For metal printers, for instance, if you, as a user, have one of M290, EOS M290, which is a fantastic, EOS is a fantastic partner of PTC. We have been doing many demonstrators. We have, using the materialized build processor interface, the possibility to send automatically from the tray assembly directly to the build processor to create the machine code needed for the printer.
All right, so my fourth question is, what about the built-in material libraries and the customization options available in your software for this additive manufacturing?
The material libraries usually come from the printer manufacturer. So we take in Creo, we can define materials 100%. We can define it there, use it for simulation and so on. I can recall, for instance, to try to exemplify with a use case. We did a heat exchanger a while ago, a couple of years ago, that basically won 4 industry awards. And in that example, I can mention, okay, we needed to simulate using the specific powder that we were using. Okay, so then the data was provided by the printer manufacturer. Then we use it in Creo to do simulation. And with that, basically, we optimize for the printability of such object. I don't see any issues on create materials, use the material information inside Creo.
Okay. Now, my fifth and final question is, how does your software address the challenges of design complexity and geometric freedom?
I think this is one of the most important aspects in additive manufacturing at the moment. A CAD system as Creo should be able to support a full end-to-end digital thread, and this is what we're doing. When I'm saying digital thread and end-to-end, is we should have full associativity between the original CAD system and all the intermediate steps. Okay, it's a process. You have a step. You create a 3D model. You put lattices. You put generative models that are very complex and so on. You define the supports, etc. But then life happens. Maybe there are some engineering changes that the original design needs to be tweaked in one way or another. Creo is fully associative and parametric. So meaning, if I define a change in my original model, all the intermediate deliverables, okay, supports, etc., can be adjusted basically in one click. So this is the value proposition of the full digital thread using Creo. I think this is one of the main value-adding capabilities that we can provide the users to address the challenges in design complexity. Design complexity is one thing, but more than design complexity is that design will change and will be adapted. And then you don't need to redo everything again and spend hundreds and hundreds of hours. So just do your change, verify it, and then propagate it downstream in the full digital thread concept.
Well, that's great. Okay, so if you are getting into additive manufacturing, those are the essential questions that you should be asking about when it comes to CAD and CAM software. And I appreciate your time today, Jose, for answering those questions for our audience. And is there anything else you wanted to add before I let you go?
Well, the additive manufacturing is a very challenging industry area, I would say, area of the industry. And I think we at PTC and as the same like all other players in the CAD industry is very busy. We are very busy working on that. Very challenging, and we are continually evolving our tools to keep up.
Well, I really appreciate your time here today. And I want to thank you for watching. And until next time, this is Sharon Spielman with Machine Design, and stay curious.